Airy silkworm, Samia cynthia racini. The domesticated silkworm, Samia cynthia racini, belongs to Saturniidae family. The origin of the name is a complex history that is perhaps linked with the sericultural practice. The larvae of Samia cynthia were believed to rear indoors, primarily feeding the foliage of Castor ricinus communis, Euphorbiaceae, which later led to the nomenclature of subspecies taxon racini. Therefore, the nomenclature Samia cynthia racini is followed here. Probably for this reason, this nomenclature is accepted by many researchers from India and is accepted internationally. The common name airy may be adopted from the Assamese term airy polu for its caterpillar, which may originate from another Assamese term era for castor. One of the primary food plants, as per another school of researchers, the Indian domesticated airy silkworm, is different from Samia cynthia. According to them, Samia racini is the entity of sericultural origin, derived centuries before through subsequent diversification from the Himalayan wild airy silkworm Samia caningi. However, many researchers use the nomenclature Samia racini, Philosamia racini and Samia cynthia racini interchangeably for the domesticated airy silkworm across the globe. The genus Samia is characterized by a striking display of pink, brown and olive tones in the adult. Hampson described the adults of Samia cynthia as head, thorax and abdomen pale brown, collar and metathorax fringed with white, abdomen with the first segment white, a dorsal white line with segmental white tufts on each side of it, wings pale yellowish brown. Forewing with a white antemedial line, outwardly oblique from the costa to vein 2, then bent back to the base of the inner margin, a narrow hyaline lunule on the discocellulars, inwardly edged with fuscus, outwardly with yellow, a postmedial fuscus, white, pink and pinkish-white band, generally curved and angled at the lunule. Sometimes nearly straight, outer area irrorated with fuscus, apical area suffused with pink, a white and dark arcellated mark near the margin between veins 7 and 8, with a waved white line from it to the costa, outer margin pale brown, a dark submarginal line dentate between veins 6 and 7. Hind wings are similar, the antemedial line oblique and not angled, some fuscous streaks on the marginal band inside the line. Distribution and ericulture. Airy silkworm Samia cynthia racini is recorded to be naturally distributed in South Asian countries, China, Thailand, Japan, Korea, Ethiopia, and the northeast region of India etc., and is introduced in some other countries of the world. In India, the northeast region and the districts of West Bengal bordering Assam are the natural abode where it is cultured traditionally. Uses. Airy silkworm is reared both on a small as well as large scale with diverse expectations for the production of silk for the textile industry and the use of silk biomaterials in medicine, pharmaceuticals and cosmetics. The prepupal stage and pupa are used as food in many parts of the world. The sericulture industry also provides women empowerment, livelihood security, employment generation, and sustainable economic growth. In Arunachal Pradesh, India, airy silk clothes are part and parcel of religious, marriage and funeral rituals in tribal communities like Naishi, aka Serdukban, Monpa, Apatani and others. Besides, fashionable modern dresses such as gale and shawl prepared from airy silk are also used widely by most of the communities in the region. Similarly, Assamese people utilize airy silk cloths to combat the winter chill and various other purposes. Ericulture is a good entrepreneur to generate sustainable employment for a wide section of the rural population. It has been reported that a large number of families below the poverty line improve their economy through airy silkworm rearing and weaving activities. Host plants. Samia cynthia racini is a polyphagous insect feeding on 2 primary and more than 6 secondary host plants from different families. These food plants mainly occur in abundance in an environment with a temperature range of 7 to 34 degrees centigrade and an average annual rainfall of 2,800 mm. The primary food plants of the larvae are the castor, Ricinus communis and Caseu, Heteropanax fragrans. The secondary food plants include Payum, Evodia flaccinifolia, tapioca, Manihot utilissima, Serra rubber tree, Manihot glaziovii, frangipani, Plumeria acutifolia, bar pat, Ailanthus grandes and tree of heaven, Ailanthus excels, which are fed during the period of scarcity of the primary food plants. Castor is reported to be superior over Caseo and other food plants in terms of cocoon weight, cocoon shell weight, silk ratio, larval weight, larval duration, effective rate of rearing and fecundity irrespective of different seasons. Life cycle: adults emerge from the cocoon in the morning till noon. The males emerge earlier than the female moths. Just after emergence, the moths start to mate. The eggs are oval with a laterally flattened surface. Freshly laid eggs are bright yellow, become creamy white, and then bluish. It is reported that eggs hatch in the morning. The caterpillars, after 4 consecutive moltings, spin cocoon to undergo pupation. They are multivoltine in nature that complete 5 to 6 generations annually. Like other silkworms, they also exhibit variable duration of life history, about 44 days in summer and 85 days in winter. They are holometamorphic with 4 developmental stages: egg, larva, pupa and moth. On hatching, the larvae are brownish yellow in color. The color changes gradually to pure yellow by the end of the 3rd day. From the 3rd instar onwards, the larvae segregate into yellow, creamy, green, blue, or white color morphs. They are translucent and covered with a white powdery substance. Yellow and greenish-blue colored larvae with and without spot are found. The spots are of various types: single, double, zebra and semizebra. A black dorsal band at the prothoracic hood is a characteristic of the first instar larva. It splits into a pair of semicircular lunule in the 2nd and 3rd instar. These markings are absent in the 4th instar larvae. The plantar, flattened end of the proleg of a caterpillar, and the anal flap and claspers are light yellow throughout the larval span. The tubercles are like a blunt thorn with setae at the tips. The larvae have 1 dorsal and 2 lateral pairs of darker spines. The cocoon may be white, orange or brown. The cocoons are open at one end and spindle-shaped. Rearing: cocoons are kept hanging using a thread or rope in the rearing room until emergence of the moths. Moths are then freely allowed to mate randomly. The female moths oviposit on the wall of the rearing house, or on a white cloth kept as background against a wall of the rearing house. The eggs laid are collected and wrapped in a paper till the emergence of larvae. Farmers use 2 techniques for rearing of the larvae: surface or tray rearing technique, and bunch hanging technique. The 1st, 2nd and 3rd instar larvae are reared using surface rearing technique. The 4th and 5th instar larvae are mostly reared using bunch hanging method, in which bunches of the host plant leaves are hanged pointing downward on a bamboo pole hanged parallel to ground surface, using rope fixed to the roof of the rearing house. Mountage: the farmers use 3 types of mountages. One type is made up of semi-dried banana leaves. Second type is made up of dried banana and jackfruit leaves with twigs kept in a jute, or plastic sack, or traditional basket, and the third type, called chandrike, is made up of bamboo. Ripened larvae are picked up and transferred to mountages. The bamboo chandrike ensures uniform distribution of larvae, which reduce the chances of forming double cocoons. Spinning, Method 1, stifling, degumming and spinning. Stifling is done by spreading and exposing the cocoons to sun for 1 to 2 days. For degumming, cocoons are tied in a cloth sack, and with the help of stone weight sunk in boiling soda solution. When sufficiently boiled, cocoons are taken out, washed in water several times to remove soda, squeezed to wring out water, and spread on mats to dry. Being open-ended, the threads of the cocoon are discontinuous and so, they can only be spun and not reeled. Spinning is done in wet condition on a spinner, takuri in Assamese, and in semi-dried condition, on a chaka, jata in Assamese. However, in these methods both the hands need to be used and so spinning becomes laborious and slow. Improved spinning machines, such as NR type Chaka and Chowdhury type Chaka, are now available, which are run by feet leaving the hands free for spinning. Method 2. Degumming and spinning. Pre-pupa. The fifth instar larvae, before being metamorphosed into pupa, are taken out from the cocoon, opening the loose end of the cocoon manually. The pupa-free cocoons are then degummed in boiling water without adding soda or other surfactant, or using traditional degumming ingredients prepared from ash of banana leaves, ash of husk, etc. The degummed cocoons are then washed in normal water and dried in sunlight. Dried empty cocoons are used for manufacturing silk yarns using takui or tapo, a traditional device used by the farmers.